Excellent. Well, thank you, Melanie, and hi, everyone. My name is Mary Fastigi, and I'm the Restoration Manager at the Conservancy. I wanted to also introduce Debbie Langenfeld, who's our Steward Restoration Lead, and Debbie has years of experience in helping us with our experimental research, and will be able to share a lot of information on why we do experiments at the Conservancy. So first, experimental research. When and why do we take an experimental approach to our work? We do experimental research when we need to ask targeted research questions. And so some examples could include asking questions about seeding techniques and what enhances seed establishment. Another one might be what invasive plant removal method is the most cost-effective, but also the least impactful on the native plant community. So these are questions that we've actually designed to help inform preserve management. And for all of these experiments, we work with scientific partners, experts in their field, like Dr. Rowe, actually, like Helen. And we then make sure that we are designing and implementing rigorous projects. And so one of the most unique and valuable aspects of our work is the fact that our experimental research and data collection is occurring within the preserve itself. And because of this, our data and the results that we are compiling are directly applicable to the decision-making that the city of Scottsdale is able to take and use for managing the preserve. And so you could say that it's customized to the preserve, but at the same time can also be more broadly applicable. And we make sure that all of our work is published in peer-reviewed academic journals, which makes that work available to the broader academic and land manager network. So you've heard from Jesse and Helen about our experimental work with bats and arthropods, and also from Bradley about the butterfly work and results on that. And for this presentation, we're going to be using examples from our invasive plant projects and restoration to show how our experimental work contributes to the preserve management and to see how it fits within the adaptive management framework that we've been talking about today. So many of you are familiar with invasive plants in the preserve, and invasive plant species are a major threat to the preserve and the Sonoran Desert as a whole. They really outcompete native plants, they increase wildfire risk, and they spread quickly. So one study that we started to engage in about 4 or 5 years ago is our fountain grass study. And it was designed to find out what removal techniques were the most cost-effective and least impactful to the native plant community, like we said at the beginning. And so this experiment ran from March 2018 until March 2021. And we set up 5 meter by 5 meter plots in quartz wash to test the efficacy and record the costs of common removal techniques. So cutting and herbiciding 1 time, 2 times per year, manual removal are examples of the techniques that we were testing. And Helen led this, and the results were published last year in Biological Invasions. And we found that all the treatments for fountain grass were effective. But the choice of what removal method you wanted to use really depended more on the scale of the issue and what your project resources were for that individual project. And also, really importantly with this project, the native plant communities recovered after removals, which is what we really want to see if we're putting in that time and resources into removals. Another problematic species that we have in the preserve is bufflegrass, and you'll hear more about bufflegrass today. And it's a very resilient and difficult to remove plant. Similar to the fountain grass study, we wanted to be able to provide land managers with information on the most cost-effective removal methods that also protects our native plant communities. And so this study ran for 5 years. We actually just stopped it and stopped the experimental work for the paper, I should say. And we also had 5 meter by 5 meter plots, and we compared the same things, the efficacy of the treatments, the cost, and the impact to the native vegetation in the same types of different combinations of manual removal, cutting, and herbicide. And we're really excited to say that just this month, the manuscript was accepted and published in Biological Invasions. So we'll be able to share out that link very soon. And we should emphasize that in the case of the bufflegrass study, not any of the treatments were completely effective at removing the grass. And so we are actually continuing treatments to see if we can get to 0. But what we did find is that herbiciding 3 times a year resulted after 5 years in buffalo grass levels that were similar to the plots that we had as controls from the beginning of the project. We also know that pulling was the least effective, but that the native plant cover and the richness did recover after removals in plots. And so our goal for both of these projects is to provide information and a toolkit that helps managers to select which treatment is the most applicable to their project. So you want to balance convenience, resources, and the scale of the infestation that you have before you decide which method makes the most sense for your project. And so we'll also take a look at the results of several of our restoration experiments. So before we get into that, I thought we should just quickly cover what is restoration and why would we worry about degraded lands and restoring them in the first place. You've heard from several of our speakers before that biodiversity is really experiencing a massive loss. And so habitat degradation is one of the primary causes of species extinctions and the loss of biodiversity. And so if you have habitat loss or fragmentation, or even areas that haven't completely been degraded, but you've lost some species through urbanization, agriculture, recreation, et cetera, you end up with less habitat for animals, you have less space for plants and that biodiversity, and so you end up with less species, and it generally leads to population declines. So we have mapped in a couple different ways how to identify where degraded lands are. One way to categorize degraded land is as open, obvious disturbances from things like off-road vehicles, unauthorized trails, camping, different uses of the preserve before it was a preserve. And so we have actually published on a citizen science-driven approach to look at where these types of disturbances are using aerial and satellite imagery. And we have found approximately 70 acres that fit this criteria. And those areas might look something like this from an aerial perspective or satellite perspective on the left side, and on the right side, you could have an old road scar that you can see kind of visually right here. Another way that you can categorize a disturbance is areas that haven't lost all of their species, but have a different species community than maybe they originally had before a disturbance. So one might be from ranching. And so this is a map that shows where the heaviest ranching impacts were in the preserve. And underneath that, if you can kind of see, there's some red hash marks, and those show where there have been fires in the preserve. And so some restoration projects could look at restoring plants that are missing from those communities to boost the biodiversity. And now I'm going to turn it over to Debbie, who is going to walk us through 4 of our restoration experiments and their results, so that we can see how we can use those in our restoration toolkit.
Oh, so can you hear me? So hello, everybody. And as Mary said, I'm going to talk about 4 of our sites, starting with the first one, past restoration. So in this case, we were able to evaluate the results of restoration areas of the preserve treated between 2011 and 2012. So these were, as Mary said, a picture on the right shows previously used roads or parking areas. 4 treatment methods were used, and I see that they dropping off the bottom of your screen. The one on the left is debris. It was we added dead tree branches that created this kind of nursery environment for seed germination. The soil was ripped to improve water infiltration. We added seeds. When this was done, they added seeds, and then cactus, mainly buckhorn cholla, was added as well. So you can see really from the picture on the right that even after 10 plus years of restoration, the communities are not meshing between the restored area and the natural areas on either side. We found that seeding was relatively unsuccessful. Our biggest success was that succulents reestablished. And then this is great. We have a manuscript that was published if you want to read more information about this in American Midland Naturalist in 2020. So our second study then is the closed trail restoration study. This was a project in the northernmost area of the preserve, and it was a 4-year study from July 2016 to March of 2020 to determine best practices for compacted areas or compacted trails. 3 treatment techniques were used in our plots that we set up. One was ripping. As you can see, we put the soil for better moisture retention and infiltration using a weasel. We then salvaged some topsoil containing seed banks, that middle one representing seed bank soil, from under nearby trees. And then we added some commercial seeds that we took painstaking details to mix them with, these seeds so that they mirrored the natural vegetation of the surrounding landscape. So the results of this study were kind of a little surprising. We found that the use of local seed bank soil was effective and shows promise as a cheap but relatively labor-intensive method, and not relatively, it's a real labor-intensive method. By the end of the 4 years, all of the plots, including those that didn't receive any treatments, resembled the surrounding natural area. So that tells us that limiting access is really an important consideration in restoration efforts. Fewer than half of the seeded species established and persisted over time. And that's kind of the same finding that we found from the seed perspective in past restoration as well. And then the unripped plots had higher native plant growth and lower non-native growth. So as Helen said, the unripped one, I was kind of surprised about that. I actually thought that the ripped ones would do better. So I guess that's why you have to do research and not just implement your assumptions. We have also a published paper for this study on restoration ecology in 2021. So the next study, the project that we're working with is called RestoreNet. The USGS, they have a team project called Restoration Assessment and Monitoring Program. And they are testing restoration treatments in 25 dry southwestern ecosystems. And we are one of Granite Mountain, near the Granite Mountain Trail. They used 4 different treatments, including mulch on the left there to help with moisture retention. Then these weird things called conmods that act as artificial nurse plants, and these wire structures that look like, they're kind of like the debris that we use in past restoration. Pits to help retain moisture, and then a couple of different seed mixes. So what did best? Well, really, of the 25 sites, the preserve had the highest seedling establishment, and that what established annual forbs and grasses did the best, including chia and senna and desert marigold. And from a grasses perspective, purple freon, for example. The pit treatment did the best across the entire network, though. And we are now working with them on phase 2, which is the testing of the effectiveness of using seed balls. You can see in that picture on the right there, those little white dots are these seed balls that we're testing. USGS has published the results, and the Conservancy is in process of doing that as well. Now, you may hear more about this. Sorry, Mary, you may hear a little bit more about this from Seth Munson, who was on the panel speaking in the next one of the next sections. And the fourth then is my favorite subject, BioCrust reintroduction. So most of you know, we're working with researchers from Northern Arizona University, including Ms. Helen, and Tanika, fantastic research partner. And you may have seen both of them presenting in Lunch and Learn a few months ago. So BioCrust has such important qualities that it really needs to be included in a restoration toolkit. But BioCrust isn't easy to come by. It takes a real long time to grow. You can't go out and buy it. It makes no sense to just transplant it from one place to another. That kind of defeats the whole purpose. So what do? Well, you try to cultivate it. So that's what we did. So it's Scottsdale Community College in 2018, we laid out an experiment using 3 different cultivation systems. So on the bottom, I'm sure you can see it, but the one on the left says flat. Then we built these hoop houses, the one in the middle. And then we also took some BioPress up to the greenhouse at NAU. And the plots had different combinations. So we laid out this wheat cloth, a weed cloth, and then the plots had different combinations of native soil and sand and with or without jute. And then on top of that, we sieved some BioPress that we salvaged at Fraysfield in 2018 again, and then put that on top. The results were fantastic. All 3 cultivation methods at least doubled BioPress cover in only 11 weeks. And native soil was found to be not really all that critical. And jute was found to be not necessary, but jute creates this kind of BioPress fabric that lets us move it around quite easily and transport it quite easily. So all of these results and findings were that we found that there was ability and possible to do some scaling up, which is really great. And so right now, many different possibilities for using BioPress. So right now we are, one of the is that we're cultivating BioPress sod at Scottsdale Community College, and we're going to be taking that out to Tonto and laying it out to help to see if we can do some build some living fire breaks. And the manuscript for this is being written right now for publication. And Mary, I think that's back to you.
Thanks, Debbie. So I just wanted to add a couple key takeaways before moving on to the next presentation. The first is that we know that land management, especially restoration and invasive plant removal, is difficult in arid environments like the Sonoran Desert. So our experimental research adds new fundamental knowledge. Jesse was talking about the importance of that for adaptive management to the toolkit for decision making. So we're also working in a dynamic and changing natural resource system. So understanding what conditions exist and being able to understand what techniques might work best in each of those different conditions is a critical piece for adaptive management and for understanding best management practices. And so we can take what we've learned from our restoration experiments and apply them while also continuously learning along the way. And so that iterative learning process is helping us to kind of prioritize areas that we want to do research in the next couple years. In the next presentation, you'll hear a bit more about our next steps for invasive plant management. So I left that off of here. But for restoration, we're planning to take what we've learned from our experiments and apply them in several upcoming projects. The first is Living Labs, and you'll be hearing from some students from Scottsdale Unified School District, Saguaro High School, and we're working with them to research and test nurse plant associations with cacti. Both it's going to be in the preserve and then also at schools within the district. And then we will be publishing results from that for that partnership. We're also going to be continuing our partnership with NAU. We have such great researchers there who are working on BioCrust, the seed reestablishment, and we're also going to develop seed sourcing guidance for the preserve. And last, we always have to communicate what we're doing. And so we're going to continue to publish. We're going to continue to make sure we are making our findings available and working with the city of Scottsdale on experiments that make sense for best management practices in the preserve and beyond.